Um, Today's session, if you don't recall, is going to be about using the Bancor dApp class, which is the main simulator interface that a user um, of the simulator would typically work with most of the time. And but we're going to start it off a little bit different today, and Mark is actually going to walk us through some examples using Excel, and then after we go through some of these examples and configure things the way that we want to, we will then jump into, well, how would we accomplish the same thing on the simulator end? So I'm going to hand it over to Mark at this point.
Can you guys see just like a gray grid in front of you?
Yes.
Hopefully. Okay, great. Okay, yeah. So the purpose of just to reiterate a couple of things that Mike said, just in slightly paraphrased. We're going to be looking today at like what are the things in the simulator that you want to do stuff with, and what kinds of properties do they have, and why do they have those properties, and what might you want to adjust and that kind of thing. And so if you think about sort of, like AMM, let's just say this, call it AMM 101 or something. Really there are, a lot of your focus is going to be on the liquidity pool itself. And then, some users in the ecosystem that are going to be interacting with it. And so, maybe you've done this before, and this is if you've tried to study DeFi and maybe you wanted to see how Bancor operates or how Uniswap operates or something, you may have actually started this way, where you say, okay, like let's pretend that we've got a
Mark, real quick,
and it's going.
I'm not sure if it's just my screen, but I'm still seeing the gray screen. It hasn't pulled up.
Oh, really?
Is anybody else seeing the same thing?
No, it's the same thing for me.
Okay.
Let me try this again.
Yeah, I wasn't sure. Are you sharing your entire screen? Let me see. Does it look better now? It's almost like it's trying to load your screen, but it's not loading it, if that makes sense. Are you sharing your screen?
Yeah. It says I've been disconnected, but patching back in.
Huh.
Weird.
Okay. That's unfortunate. Okay, give me 1 second. Maybe it's my VPN.
Yeah. Show your screen share before you disconnect your VPN. There we go. I can see.
Okay.
Yeah. Okay. You're good
Perfect.
Now. Okay. So like if I type stuff in here, you can see that.
Yes.
Yep.
Okay. Good. All right. So apparently my VPN was screwing it up. Okay. So where was I? Yeah. If you try to sort of emulate an AMM on your computer before, most of the time you're going to be doing it in something like Excel, just because it's a tool that I assume most of us have access to and feel comfortable using, and that's totally a legitimate way to begin stuff. And what I'm hoping to do with this introduction is basically show you that a lot of the objects that we have in the simulator can seem sort of nebulous and scary and unintuitive the first time that you see them, because it's just lines and lines of code. And so what Mike and I are going to demonstrate today is that the same kinds of categories of information that you would be putting into your Excel spreadsheet, they have an equivalent representation in the simulator. And just like you would input values into Excel cells, you can input those same values into the simulator and then ask much more sophisticated performance out of the simulator than you can out of Excel. So for example, one of the things that you might say is, okay, let's consider a USDC BNT liquidity pool. And you might say as well, because blockchains are all time dependent, is you might want to start this at like sometime 0, and then have a bunch of actions that take place as you move forwards in time, right? And hopefully this is pretty intuitive so far. So let's imagine that we have just like a liquidity pool that starts with like 1,000 BNT and 1,000 USDC. There are going to be other parameters, associated with this pool, things like the swap fee, right? And then also things like the vortex fee, which is actually going to be like a global parameter, right? So let's put this up here under its own category and say, we'll call this the global parameters. But for the pool, right, the swap fee is only associated with that, right? So these are the things that are sort of network wide, and then these are the things that are specific to the pool. And so let's start with our swap fee of 0.001, something like that. Okay, so what I want you to realize here is that we've got this, this column here is just monitoring like how all of these things are going to be changing over time. And then we've got this object here, right, which is all by itself, that has, these attributes associated with it. And so really, like, this is an object in the simulation. Now, we're also going to have, users, right? We might have Alice, and she is going to have, a BNT and USDC balance, and she might have other things as well, right? Maybe she's got Link and ETH and all of these kinds of things. So Alice is going to be one component of this, and she's going to be her own separate object inside the simulation. But if we want lots of people, swapping against this pool, then we might also want to have, Bob and Charlie and so on and so forth. So let's say that we're going to have just these two users, and because we want to put them on the same time scale, you might sort of slide them up and over to the right or something like this. And so at time 0, we want to know, the balance of the liquidity pool and, its swap fee setting. And then we also want, like Alice to have, some balance of all of these tokens. And then we'll probably want Bob to have those same balances. So this as well, and I'm kind of, darkening the things that are their own objects. So we know this is going to be an object. And we also know that Bob is going to be a separate object, right? These are each unto themselves their own, they have their own unique identity inside the simulation. And so then what we might do is, we can set the swap fee to 0 for now, just to make this nice and easy. We can ask questions about, okay, like how do these things evolve forwards in time, right? So if this is the first state, what would be the second state if a user performed a certain action? And so now we're thinking, okay, we need, another, another way to represent stuff, which is going to be sort of, actions performed, I guess. And so we're going to have the same sort of time sequence here. And these actions are going to affect, different objects in the system. So we might have, time, action, user, and, amount or something like that. And so the action could be something like, let's say trades BNT for USDC, right? And that Alice, that user will say is Alice, and let's say that the amount that she's trading is one BNT, okay? And so this is happening on state 0, okay? So we might look at this and say, okay, on state 0, which is going to affect the next state, which is going to be state 1, Alice added, 1 BNT to this pool. affected the balance of USDC. Swap fee was 0 in this case, so we don't have to worry about that, which is nice. This is a slightly less trivial calculation. And we're going to see, okay, well, how did Alice's balance change? Well, we need to subtract the 1 BNT that she added to this pool, and we need to add to her balance the amount that was the amount that used to be in the USDC pool, for example. And then, her other balances didn't change and that kind of thing. And we can do this, as much as we want. And, we've got a snapshot now of, what the state used to be before she performed that action. And we know that she performed that action at that state. And now we know what the following state of the simulation is. And so what we're going to be looking at today is just how to create these kinds of objects, how to give them, all of their, all of the attributes that you might want in a simulation. And, and then I think in the next presentation, so the one at the end of this week, we're going to be looking at how to do this part, right? How to create the action, how to choose a user to perform that action, and how much to give them and that kind of thing. But really, for an AMM, this is kind of almost everything that you need, right? There's going to be some global parameters that are set that affect the entire network. And then there's going to be things inside the network that inherit some of those properties, as well as having their own specific properties. And then there are things that are interacting with the network, which is almost always, some user address. And then we want to give them certain properties, such as token balances. We want to give them some sort of behavioral bias or something like that. And so the reason I'm showing you this in Excel is so that when we go into the simulation code and have a look at what these things look like in Python, if it seems scary, I just want you to remember that you can translate all of these things back to just an Excel spreadsheet and just think, okay, all we're doing is naming stuff and putting numbers in cells. And so I think with that, I'm going to stop sharing my screen and I'm going to hand it over to Mike, who's going to be showing you exactly how to create these objects, how to assign their properties, and then at the end of the week, we'll be looking at how to make them do stuff.
Cool. Okay, so I'm going to share my screen and let me know if you can see it or if there are any issues.
Good for me.
Cool. All right. So when we open up the Jupyter Notebook, which is, by the way, just kind of assumed to be the main environment that you would be using this, pretty common in data science throughout industries, and we import our Bancor research library, which once again is an installable. You can look at the docs for how to install that on your system. And once we import this class, which we're talking about today, the Bancor dApp class, which is meant to imitate what users can do through the actual dApp that you might be more familiar with, right? You use it on your phone to deposit liquidity or withdraw or make a trade. And so we're using this class to represent a lot of that same functionality, but also some additional functionality, which of course, as just a front-end user, you would not really worry about. So we can basically import these the classes that we want to have a look at, and we can call this just v3. So once we initialize the class, we'll just refer to it, shorthand as v3 from then on. And right away, we'll just go ahead and we'll do this describe method. We'll call that, and that is going to return what we're looking at here, which is very much like an Excel spreadsheet. It's a pandas data frame, and it's organized in such a way that we can kind of look at the balances change when we do something, right? So we can describe the system state at the current timestamp by just calling that describe method. Referring back to what we did last time, just briefly, we were looking at the state class. And so how does the Bancor dApp relate to the state class? In this next cell down here, you can see we can just call v3 get state, and that's going to return the current state of the system and all of the different classes that are associated with that state. And so right away we can say, okay, well, what are the default whitelisted tokens that we have when we initialize a state from scratch? And the answer is there's a couple of just default values which are hard coded in so that it's a little bit easier just to get started without having to configure everything entirely manually. You can just kind of get up and running quicker. And so those default tokens are going to be ETH, LINK, just a general TKN, which could refer to any token besides BNT typically, and WBTC. So there's some associated parameters with each token. These are configurable by pool, right? So for the ETH pool, we have a distinct trading fee, which can be set, which is different than the link trading fee. Same thing with the BNT funding limit and the external protection vault balance. So the decimals, you don't ever really need to worry about configuring these. You can just kind of leave it at the default 18 unless you want to get really specific with something, which is fine. But in general, you can basically ignore that and worry about the three main parameters, which you would likely be interested in, for any given pool. And so this structure right here, this is called a dictionary, if you're not familiar with it. So you could add other tokens to this dictionary, and let's we can just do this real quick if you wanted to. Copy that same structure, and we could say, well, let's go ahead and add something else here. So add another comma, and we could say we're going to add the mic token, and we're going to have just these same things. And now this would effectively change the state. I'm going to print this again after. So now we say the state whitelisted tokens equals this new dictionary, and then we're going to print it out at the bottom here again. We can see we now have a token called mic and whatever parameters are associated, right? This, of course, is not any longer. We're handling the state as an independent object from like the V3 system as a whole. And so we're going to look at in just a moment how to like recombine those things. But I guess let me try to follow along closely with what Mark was doing there. So from there we can look at the users that are associated with the current state. I've already created these. Let me go back and do this one more time. I'm just going to print this instead of play with it. Right, so the users, it actually does not have any default users associated with it, but we can add them, right? And so Mark had mentioned a couple users, which we're calling Alice, Bob, and Charlie, and a couple associated pools, which we had USDC and BNT, I believe. And I think that the balances that Mark used were like 10, 10, and 10. Whoops. 10, 10, 10, And I was actually just Alice. Yeah, I'm sorry. I think it was ETH, BNT, USDC, and this was just Alice. What was the other one? Link, right?
Yeah, link.
So we can do, great. Now I'm just going to copy the same thing. Okay, so now we've got we're going to initialize these users with these balances, and we're going to do a quick check here. In fact, we're going to have to do, so I'm going to loop through these things so we don't have to, we can do them each individually by calling, in fact, let's just do that first. Let's do create user, which we're going to say Alice, and then we're going to create a user Bob, right? And then that way down here, we don't have to worry about this. And so after we create Alice and Bob, then we're going to loop through this this list, and we're going to provide an initial starting balance for each of these users. So we're going to say v3 set user balance, and we're going to provide the username, the token name, and the token amount that we want to set, as well as the current timestamp. And so after we loop through all those, then we'll call the system describe again, and we should see the balances update. So let's give this a try. Okay. After we hit an error during the live session, I've gone back at this point and reworked a few things in order to troubleshoot the problem that we heard earlier, which was actually turned out to be quite trivial. As always, there's a bunch of different ways that things can be done, and the particular way that I was trying to add the whitelisted tokens was maybe a bit more manual than we needed to do at the moment, and it also happened to be one of the ways where there was not a sufficient error message to make it totally obvious right off the bat what it was. But basically, whenever a token is whitelisted, there's an assertion that is made which requires the whitelisted token to have a corresponding price feed. The price feed is of course needed when you're running like a real simulation, but it's not necessarily needed just at the initialization point of like a demonstration like this, right? And so I went ahead and changed the code to disable the assertion that there needs to be a price feed right at the very beginning of this process, so that we can whitelist tokens without that throwing an error. So with that, we're going to run through this one more time, where we import the Bancor research class or library, the Bancor dApp class, and we can go ahead and initialize the class and then call describe to get the system state. And we can see that everything is zeroed out to begin with. This is once again our pandas data frame, which basically prints out the system state balances. Now we're going to go ahead right off the bat and we're going to whitelist USDC, as we see that we've got BNT, ETH, Link, TKN, WBTC, as well as the corresponding pool tokens, and VBNT. But we do not have USDC, so we're going to go ahead and do that, whitelist the token. And then we can call get state to get the state, and we'll print the whitelisted tokens of the current state. So we can see here that USDC was added as expected now without issue. We can check the initial users and see that it's just an empty dictionary. There are no users right out of the gate. So we're going to go ahead and create those users, and then we'll check again by calling get state one more time, and then printing the users. We can now see that we do have Alice, we do have Bob, and they have a bunch of associated data with their current system state. So at this point, now we have 2 users. They have balances of ETH, Link, BNT, and USDC for an amount of $10 each. We can confirm that by calling our describe again. And because I'm lazy, I'm just going to copy and paste that. We'll go ahead and add another cell down here, and we can see that indeed Alice has 10 BNT, 10 ETH, 10 Link, and 10 USDC, right? Bob has the same thing. The rest of the balances remain at 0, and that's what we were looking for. Just to kind of bring home a couple more points while we're here, is we can check the BNT min liquidity of the current state. And now suppose we want to change this value to 1,000, right? We could just do this state BNT min liquidity equals 1,000, and then call v3 and then reset the state to the change state, right? So the idea is that the Bancor dApp class keeps the existing state, right? And doesn't modify, and we call whatever state that is associated with the v3, the Bancor dApp class, of which v3 is an instance. We say that this is our global state, right? And that wherever we're using this state variable, this is quote unquote our local state. So we can change the local state as we go through the process, and without changing the global state, right? So let's say that Bob tries to withdraw more money than he has in his wallet, right? Well, we don't want Bob's attempt to withdraw that, passing them through to our global state unless of course that's a valid transaction. And so in the contracts, this is called like a revert, which means that basically the state reverts, and the same sort of behavior is happening here, where we don't update the global state until the end of an action, and the end of the action, then we'll go ahead and do that. So you can see here that we can set the BNT min liquidity and then call v3 set state, in which case the new value will be the 1,000 that we set. So let's go ahead and just run that. We can see here that up here we had 10,000, and we've now changed it to 1,000 as expected. There's pretty much a get function for most parameters of the system. So you should be able to call like get BNT funding limit, right? And we pass in the state, and we can pick a token that we want to get information about, and that should be returned accordingly. Now we could say, what if we want to set the BNT funding limit? Well, we can just say state tokens and BNT funding limit. We can set the state accordingly, and then we can call get again just to see that in fact we did update the parameter that we were looking to update. And so all of these parameters can be updated, configured in very much the same way that we've done here without much of an issue. So with that, I'm going to go ahead and wrap up this video, append it to the one where we hit an error, and we will pick up next time going through some actual trades, deposits, withdrawals, and performing some actions now that we know how to configure the user state.